Hi, this is Mr. Anderson, and today I'm going to be talking about position versus time graphs. First thing you should know is that this is part 1. I'll also do a part 2 on position versus time. Part 1, I'm going to talk about objects that have constant velocity, and in the next part 2, we'll talk more about acceleration and deceleration. And so if you're in the wrong spot, make sure you start where you should. Now, what do I mean by start? This whole unit on position versus time graph and graphing in general is designed so that, let me graph out a quick one, like that, and then let's say it goes like this, and let's say it goes like this. So the whole thing is designed so that when you are done with this unit on graphing, you should be able to take a graph like this, and I know that's not super great, but you should be able to take a graph like this, a position versus time graph, and just looking at it, you should be able to figure out exactly what this object is doing. Not only should you be able to figure out what the object's doing, you should be able to go from a position versus time graph to a velocity versus time graph, and then from a velocity versus time graph to an acceleration versus time graph. In other words, it's taken me a long time to do this, but I can literally draw it. So if I say this is the origin, so we say this is a velocity of 0, I can look at this little unit here and I can figure out that it's going to have a velocity of like that. And then it's going to have a velocity of like that. And then the velocity is going to go like that. And if you don't know how to do that, like that, then you're in the right spot because we're going to start right here. If you do know how to do that, and then to go from here to an acceleration graph, then don't watch these videos because you clearly know what's going on. So let me clear that off. I'm sorry, I got a little into that. And let's get started. Best place to start is with the Moving Man. Now, what is the Moving Man? Moving Man is a simulation that was created at University of Colorado. And what they do is they move a man about, and you can actually start to play around with position versus time graph. And so if you're struggling with this, please go there. And even if you're not, please go there. And that's what we're going to do as well. So here's the Moving Man. And if I hit play at the bottom, now I've pared it down so I really only have the simplest things. You also could have velocity and acceleration, but since this is position versus time, I'm just going to start there. And so I've hit play, and what we can see is that our man is not moving, and so our graph keeps him right at 0. Okay, so that's kind of boring. So let me clear that again. And let's play it again. So what you can do is I can input the man's position. So I'm going to move the man to 5. And what you see is the man up here quickly moves to position 5. And you can see that reflected in the graph down here. So let's move him to -5. Or let's move him to 8. Or let's move him to 6. Or let's move him to -8. Okay, so if I pause it right here, let's look, and you can hit playback, and then we could watch what happened. And so for the first period of time, he was at position 0, and then he quickly moves to position 5. And so what a position versus time graph really tells us is where he is or she is. He then quickly moves back into the negative, and then back into the positive, and then a little less positive, and then finally moves into the negative again. And so if you see a position graph like this, position is always going to be graphed on the y-axis, and time is always going to be graphed on the x-axis. If you see a graph like this, it simply is a man positioning himself in different positions. Now, it's a little unrealistic. In other words, we cannot move that quickly. And so let me move him back to position 0 and show you what it might look a little bit more like. So let me play it again. And what I'm going to do is use this dragger to actually move him in a natural fashion. So let me try to move him in a natural fashion to position 5, and then let him rest there for a little bit. Now let's move him back, maybe to position 1. And then way down here very quickly into, it looks like position 4.5, and then let's have him rapidly go up here at the end. Okay, now let's watch that, because I was controlling it, so it was hard for me to watch. So let's watch what happens. So there's a long period of time when the man is not moving. but then the man moved from position 0 to position 5. And so that should be a straight line when I was trying to do it. And so what that straight line indicates, let's try and go back and see if we can see that again. Let's watch his behavior as he goes. It's a little jerky, but you can see that the man is moving. And since this is a straight line, the man should be moving at a constant velocity, or in other words, he's not accelerating. Let's see what happens. Watch again. Okay, now the man moves back. So the man moves back to this position like position 1. And the speed here, let's go look at that. So the speed of the man's movement right here, watch how fast he's moving. And the speed of the man's movement over here, let's go way back here again, is constant. And so what does this mean when the line is moving up? It just means that the man is moving to the right. And what does it mean when the line is moving down? It means the man is moving to the left. Now, this line looks a little bit steeper, so let's watch what happens. Can you see how the man's moving faster? And now let's watch the man at the end. The man, whoa, really moved. And so the slope of this line also tells us the speed. And so that's the first rule. First rule that you should pick up, at least that I've picked up, is that the slope equals the velocity. And if there's no slope, so if slope equals 0, then the man's not moving at all. So here. If the slope is negative, then the velocity is negative. And it doesn't mean that it's somehow going slower. It just means that it's moving in the opposite direction. So it's moving down like that. And so that's what you can learn from moving man. You can move it back and forth, and you can try to figure out what position versus time graph is. Now, on our test, we don't have to play with the moving man. On our test, we have to solve problems. And so let's get to some actual problems. So what do we have here? Now, we're not given the man, but we're given the position versus time graph. And so knowing what you now know, what does this mean? Well, first of all, it's a slope. It's a positive slope, and that means the man is moving. Where does the man start? At position 0 and time 0, and where does the man end? At position 6 and at time 3. So what did the man do from here to here? The man walked, and walked with a constant velocity. Now the cool thing is that we can actually use the slope of this line to figure out how fast the man is walking. So what's the rise in this? Well, it goes from 0 to 6, and so the rise is going to be 6 meters. What's the run? It goes from 0 to 3, and so that's going to be 3 seconds. And so the velocity in this case is actually 6 meters per 3 seconds, or 2 meters per second. Now, we learned in the last podcast that velocity is position final minus position initial over time final minus time initial. And that's all we're doing in slope. In other words, the slope of this line is giving me the velocity of that object. So to solve that in a more roundabout way, let's kind of go down to this next one. So let's go right here and figure out the velocity of the man here. Well, if we look down here, the final position is 3 meters. The initial position is 6 meters. The final time is 8 seconds, right here. And the initial time is 5 seconds. And so this should be negative 3 meters divided by, well, 8 minus 5 is 3 seconds. And so during this period of time, the speed of the man, or velocity, is negative 1 meters per second. And so our speed here was 2 meters per second. Our speed here is 0 because the man's not moving again. And then down here it's negative 1 meter per second. And then finally it's 0 again. And so if we clear this off, again, a goal was to be able to graph that. So I'm going to graph this as, put this as 0 velocity right across the middle. And so from position 1 to position 3, so from position 1 to position 3, what was the velocity? The velocity was, and let's make this 1 and make that 2 on our scale. So from here to 3, the velocity was actually 2 meters per second. It's going to be a straight line. Now, what was the velocity from this period? So from period 3 to period 5, so time 3 to time 5, is actually 0. So I'm going to draw a straight line right across here, and then you can connect that with a vertical line like that. It should be straight vertical. Okay, so the velocity was 2 meters, then it was 0 meters per second. What was it during this period of time? We just calculated it. For the next 3 seconds, 1, 2, 3, it was negative 1 meter per second. So 1, 2, 3. It was negative 1, so we'll call this negative 1 right here, and this would be 1. And then what was it at the end? At the end, it was 0 again. And so this would be the velocity versus time graph for that object. It was going a constant speed in the positive. In other words, the moving man was moving to the right. He then paused for a little bit of time. He then went in the opposite direction, not as fast. You can see that the slope of the line is not as steep as it was over here. And then the man waited for a period of time. And so that's how you'd go from a position versus time graph to a velocity versus time graph. And the easy way to do that, position versus time to velocity versus time, is just to figure out the slope. Because if you figure out the slope of the position versus time graph, that'll always tell you the velocity versus time graph. If that doesn't make sense, go play it's phet.colorado.edu. Play with the missing man or the moving man and then take a stab. Now, if you play around a little bit, what you're going to find is that it's not always as straight. In other words, when we were doing it, moving man was moving straight to here and then resting and straight to here and resting. But in this graph, you see that it's actually a curving line on the velocity. And what that means is, or on the position versus time, and that means that its velocity is changing. So you could try to figure out what the velocity versus time graph is, or you could watch Position versus Time Part 2, and I'll give you some tips. So I hope that's helpful.